Hello everybody, Root Beer here. Thanks for joining me once again as we continue our look at the 2006 Gauss paper, the grade 8 Gauss. And we're on question 12, the very second question in B part, where the questions are worth just a little bit more, and as such, are just a little bit more challenging. So, in the diagram, what is the area of the shaded triangle? Okay, so we got a shaded triangle, and we have a box around it, a rectangle. And we know the base of this triangle is 10 centimeters, and we know the height of the rectangle is 3 centimeters, 10 centimeters, 3 centimeters, and we want the shaded area. Okay. Now, usually when they give you a shaded area style question, the best way to go about doing it is to realize the shaded area as a sum or difference of areas that you already know. So in this case, you could say, well, if the shaded area is the whole rectangle minus these two smaller right-angle triangles. Okay, and these right-angle triangles have height of 3, and the rectangle is 3 by 10, so we can definitely get 30 there. But when it comes to doing it this way, we don't know the bases of these right-angle triangles. You could say it's x and 10 minus x, and if you really wanted to, you could slog through that, and the x's actually don't matter, and you'd be all set. So if you've been doing a lot of contests, that might be your instinct, but this actually isn't the best way to go about doing it. It'll get you there, but then you have to put this x in there, and not everyone's going to say, aha, algebra will make this harder, but then easier. So really, with this one, we have a base given to us for the triangle. We're told, oh, that's a terrible triangle line. We're told that we have a base of 10 centimeters. It's there in the original question. Well, in the original diagram. If only I knew, say, a height. Okay? But this height is going to be parallel to these other, the heights of the rectangle. We knew both of them are 3. So the height of this rectangle is going to, or sorry, not the height of the rectangle, the height of the triangle is going to have to be 3. And we want the area of this triangle, so that's going to be 1/2 base times height. 10 divided by 2 is 5, times 3, 15. And 15 is going to be our final answer. So 15, I guess they had centimeters, so 15 centimeters squared, but matching up the units doesn't really matter in the end. I've never seen them mix up units in a question. So never given you an option in centimeters and decimeters and meters and kilometers. So there's no actual real need to carry through the units. But if you're that sort of a person, if you're destined to be a physicist someday, that's a great habit to get into. Okay? But that's question 12, and this is always the case. If you have a triangle and you put a rectangle around it, so it's the smallest possible rectangle that can contain your triangle, then your triangle is going to be 1/2 the area of your rectangle. Okay? So, that's question 12. Onward to question number 13.